Part 1, show that I times e to the power of I pi over 6 equals e to the power of I pi over 3, all squared. Part 2, solve in the complex numbers the equation z squared minus 2 times e to the I pi over 12 times z plus open parenthesis 1 minus I close parenthesis times e to the I pi over 6 equals 0. Part 3, in the complex plane with orthonormal coordinate system O, U vector, V vector, consider the points A, B, and C with affixes. ZA equals e to the I pi over 3. ZB equals e to the I pi over 12. ZC equals e to the I pi over 3 plus e to the I pi over 12. Question A, show that the quadrilateral OACB is a rhombus. Question B, plot the points A, B, and C in the coordinate system. Question C, compute the area of the rhombus OACB. Part 1, show the identity. We want to show that I times e to the I pi over 6 equals e to the I pi over 3 squared. First, remember Euler's formula. E to the I theta equals cosine theta plus I times sine theta. Also, recall that the imaginary unit I can be written as e to the I pi over 2. Because it lies on the unit circle at an angle of pi over 2 radians. So, our left-hand side becomes I times e to the I pi over 6 equals e to the I pi over 2 times e to the I pi over 6. When multiplying exponentials with the same base, we add their exponents. Pi over 2 plus pi over 6. Let's put them over a common denominator. Pi over 2 is 3 pi over 6, and adding pi over 6 gives 4 pi over 6. This simplifies to 2 pi over 3. So, the left-hand side becomes e to the I times 2 pi over 3. Now, the right-hand side. E to the I pi over 3, squared. Squaring means multiplying the exponent by 2. 2 times pi over 3 equals 2 pi over 3. So, the right-hand side is also e to the I times 2 pi over 3. Since both sides are the same, the identity is proven. Part 2, solve the quadratic equation. We have z squared minus 2 times e to the I pi over 12 times z plus 1 minus I times e to the I pi over 6 equals 0. Step 1, identify the coefficients. A equals 1. B equals minus 2 times e to the I pi over 12. C equals 1 minus I times e to the I pi over 6. Step 2, compute the discriminant, delta. The formula is delta equals b squared minus 4ac. First, b squared. B equals minus 2 times e to the I pi over 12. Squaring gives minus 2 squared times e to the I pi over 12 squared equals 4 times e to the I pi over 6. Now, 4ac equals 4 times 1 minus I times e to the I pi over 6. So, delta equals 4 times e to the I pi over 6 minus 4 times 1 minus I times e to the I pi over 6. Factor out 4 times e to the I pi over 6. Delta equals 4 times e to the I pi over 6 times 1 minus I. Inside the brackets, 1 minus I equals I. So, delta equals 4 times I times e to the I pi over 6. From part 1, we know I times e to the I pi over 6 equals e to the I pi over 3 squared. So, delta equals 4 times e to the I pi over 3 squared. Step 3, square roots of delta. Since delta equals 2 times e to the I pi over 3 squared, its square roots are plus or minus 2 times e to the I pi over 3. Step 4, apply the quadratic formula. The solutions are z equals b plus or minus square root of delta over 2a. Here, b equals 2 times e to the I pi over 12. So, z equals 2 times e to the I pi over 12 plus or minus 2 times e to the I pi over 3 over 2. Divide through by 2. Z equals e to the I pi over 12 plus or minus e to the I pi over 3. Therefore, the solutions are z equals e to the I pi over 12 minus e to the I pi over 3. Z equals e to the I pi over 12 plus e to the I pi over 3. Part 3 Geometry in the complex plane. We are in the complex plane with an orthonormal coordinate system. Points. A has affix e to the I pi over 3. B has affix e to the I pi over 12. C has affix a plus b. A. Show that OACB is a rhombus. Since ZC equals ZA plus ZB, vector OC equals vector OA plus vector OB. By the parallelogram rule, OACB is a parallelogram. Also, OA equals OB equals 1, so adjacent sides are equal. A parallelogram with equal adjacent sides is a rhombus. B. Approximate coordinates. Point A, 0.5, 0.866. Point B, 0.966, 0.259. Point C, 1.466, 1.125. C. Area of the rhombus. Area equals OA times OB times sine of angle AOB. The angle is pi over 3 minus pi over 12 equals pi over 4. Sine of pi over 4 equals square root of 2 over 2. So the area is square root of 2 over 2. Final results. 1 identity proven. 2 solutions, z equals e to the I pi over 12 minus e to the I pi over 3. Z equals e to the I pi over 12 plus e to the I pi over 3. 3 shape is a rhombus, coordinates given, area equals square root of 2 over 2.